Good evening. So today we are talking about the law of conservation of momentum, and this is something called Newton's cradle. And so these are steel balls that are actually very springy. They have a super high elasticity, which means that they transfer the energy from one ball to the next um, almost 100%. And they are equal in mass. And so what that means is when they hit each other, the law of conservation of momentum basically says that whatever momentum you have going in, and oftentimes we're talking about like things that are colliding, like in a collision, right? So the balls are going to collide with each other, and whatever momentum you have come in is what momentum comes out. So if I take one ball, no matter how it collides, one always comes out. And since these are equal mass, then now I can take two balls and to come out. And so what if I take three? Three come out. And then, of course, if I can grab four, there we go, then four come out. This one is not exactly like the one you would have in class, because in class I could grab two from one side and I can grab two from the other, and they actually let them go at the same time, and they go. And whatever amount you drop from one side comes out the other side. It's actually pretty cool in class. But this one is a very good animation, but it's not complete because you can't grab a ball from two sides. Maybe if I got two mouses, I could do that. So anyways, this is a good example of, to begin, the law of conservation of momentum. Okay, so what are we talking about then? So law of conservation of momentum. First of all, what is momentum? And just to review a little bit. So momentum is the letter P, which is the Latin word petere, and that means to go. And it is when a mass is in motion. And so it says a 5 kilogram object moving 1 meter per second. So the momentum of the 5 kilogram object, mv, is going to be zero point 0.5 kilograms times 1 meter per second. And you get your momentum. Your momentum is 0.5 kilogram meters per second. Ta-da! Okay, so what we're going to do is we're actually going to take it and we're going to collide the object with something else. And so we'll collide it with another object. And so I'm going to move that up so I can kind of still see this in what's going on. So they're going to collide with another object. Maybe I'll move myself up here too. Okay, and let's look at another thing we have going on here. And so here's my 0.5 kilogram object. It's moving 1 meter per second. So as it goes, it's going to strike this second object. And the question is, what will happen? Well, what we do know will happen is this object has a momentum, which is 1 times 0.5. And this object has momentum, which is 0, because it is the mass of 1 times 0 is 0. So when this hits, and I have that fully inelastic, I'm going to do an elastic collision. An elastic collision, I need to start over because the elastic collision is going to bounce off of each other. The inelastic collision is something we'll do a little bit later. So when it hits, they hit and they go off each other. Okay, so the question is, when I started, how much momentum did I have? And when I finish, how much momentum do I have now? Okay, and so that's what we're going to look at mathematically. If you look right here, the velocity as this goes backwards is 0.33 meters per second. So let's remember that as we go back to the other page to work this out. So this is a mass of 0.5, which is the green one, and it's got a velocity of 1. And so if I go, click it and go, let's just remember this number, 0.33. Okay, so we're going to go to the other thing. So the way we do this mathematically is we add up the momentum before. And so this is called an elastic collision. An elastic collision is the ones that bounce off each other. They perfectly bounce, and so they conserve kinetic energy as well as momentum. So the law of conservation of momentum doesn't say energy is conserved. It says that in the collision, that momentum is conserved. And we'll talk more about law of conservation of energy later on. Okay, so this says that if we have a collision, and I'm going to kind of break it down here where this is the actual collision. If we have a collision, then the net momentum, so the P net before the collision, will be equal to the P net after the collision. And so they will be equal. And this is the P net. And I don't like that N, so let's chop it off right there. That didn't help much. It looks like ret. I'm a mess right now as far as drawing is concerned. Okay, why is that a big deal to me? It's not. It's the net momentum, and it is before the collision. So how do we do that? We're going to typically deal with 3 items. Sorry, 2 items, 3 items. It's getting late. With 2 items, right? So I have this ball here, and this ball has a mass of 0.5 kilograms, and it is moving this direction with a speed of 1 meter per second. And it is going to collide with another object, and this one is going to be 1 kilogram, and it has no velocity. Okay. Afterward, what we said is this object is the 0.5 kilogram object, and it is going to move backwards, as we saw, at a negative 0.33 meters per second. Now, you may have had eagle eyes, and you may have seen what is going to happen to this 1 kilogram ball. Maybe you saw it. Maybe you had quick eyes. I'm not going back to it yet. I'm going to solve this. So what should this be is the question. V equals question mark. And so how do we solve that? We solve that with a little bit of algebra, right? So the algebra looks like this. I'm going to do the net momentum, and momentum is mv. So this is going to be mv, and this is technically, this is m1 v1, and that's before the collision. And this is also mv, and technically this is m2 v2. And this total will be equal to this total here. And so this will be m1 v1 again. If we wanted to, we could call this M1 V1I for initial, and we could call this M1 V1F for final. I will lock up. That's right. Okay. It's getting late. The janitors are leaving. So, all right. So this will be over here. This will be M2 V2 final, right? Okay. And they're going to be equal. That's a law. That is a law of conservation of momentum. Okay. So what do we got here? We got easy. We got 0.5, and we got 1, and then over here we got 1, and we got 0, right? So what is this total? This total is 0.5 plus 0, and so now I got 0.5 on this side of the equation equals. That's some pretty easy math there, right? Over here, I've got a 0.5. The mass is still the same. The mass didn't change. Same object. But this time it's going to negative 0.33 meters per second. And I got my calculator right here. 0.5 times 0.33 equals a negative 0.165. Plus my mass, that's unknown. That's 1. 1 times V, and V is my question, right? I'm trying to find that. That's my unknown, right? And your unknown should always remain as the unknown variable in the question, right? And so I filled in everything except for my one unknown. And so here I got 0.5, and then here I'm going to add 0.165 to each side. And I get the answer is 0.665 is equal to V, because that's 1V, right? All right, so 0.665, and that's a positive, right? And this is V, so it's meters per second. So let's go back to the other page and see if we have these 2 items. So what we should have when we look is we should have, at the beginning, we should have 0.5 times 1, that's MV1, That's 1 mv. And then plus, we should have 1 times 0, right? That's the second object's mv. And then this should be equal to, what did I say? 0.5 is the same mass, mv, times a negative 0.33 plus a 1. That's the second mass times velocity times basically a 0.67 positive. I just rounded it off. That's what we should get when we look back at the other page. This would be the law of conservation of momentum. And let's see if we go back there. What did it say? And there we go. There we have it. So if I replay that right now, I could show momentum there. That'd be the momentum. I guess it didn't help me with my numbers. Yeah, that doesn't really help with my momentum numbers. Anyways, so I'm going to go back to velocity. So that's the velocity, and it hits it, bam, and they bounce off in opposite directions, and we got our answers there, okay? And so that's the first part of what we do in this worksheet.